Okay, this is for interference patterns, and when we did these problems in class, it was, remember I set up two speakers in the room and we put out the same frequency out of both speakers, right? And then if you were in some spot like this, let's suppose you were here, right? There's some distance L1 to this speaker, and then there's some distance L2 to this other speaker, right? Okay, if we subtracted those, if we took the absolute value of L1 minus L2, that would be our path difference. And if that equaled 1 times lambda, or 2 times lambda, or 3 times lambda, an even number of lambdas, some number of lambdas, 0.0, right? Then that was constructive interference, right? So this guy is constructive, right? And if L1 minus L2, in other words, if the path length, right, the path difference is what we're talking about here, right? If that was a half a wavelength, 1.5 wavelengths, right, 2.5 wavelengths, then this was destructive, okay? Okay, so for these types of problems, the first thing you want to do is you want to find lambda if you have to, right? Find the path difference, right? Divide by the wavelength. I did this today too. Divide by lambda, right? Divide by the lambda, right? And then think about it, right? If it's some number, 0.0 or close to that, then it's constructive. If it's some number, 0.5 or close to that, then it's destructive, right? So if it's 0.0, 1.0, 2.0, 3.0, 72.0, right, it's constructive. If it's half 0.5, 1.5, 2.5, 3.5, 72.5, it's destructive. So that's how you do these problems.